Hey guys, in this video the brilliant Mr. B is going to be taking you through working out the area of quadrilaterals. Now there are 15 different examples here at 3 different levels, and you can use the pinned comment to jump between these, moving as quickly or as slowly as you feel comfortable. If you want more examples, either in a workbook or multiple choice questions, then there are thousands waiting for you over on my website.
We're going to have a look at find the area of quadrilaterals. Now you might think we've covered this already, and in the last video we looked at area as well, and we looked at area of quadrilaterals, but the quadrilaterals we looked at were rectangles. So the area of a rectangle we went through, and it was the base of the rectangle multiply the height of the rectangle, and base and height can be quite ambiguous. Shapes can be rotated around to make it not clear. So the key thing here was that the base and the height are at right angles to each other. So looking at question 1, if I highlight the base in blue, we can see there is a right angle on that base, and the right angle is joining with a line that goes upwards. So that means that the blue line is the base and the green line is the height. So if question 1 was a rectangle, then the base would be 100. Now that's not labelled on the diagram, but we can see that the label at the top is 100, and since this seems to be a parallelogram, then they're going to be the same length. The height is 133, and so to get the area of that shape, if it was a rectangle, we would multiply together those two numbers. Now I'm not going to do that just yet because clearly it's not a rectangle, it's a parallelogram. What's the formula for the area of a parallelogram? Well, there's a little trick you can do with parallelograms to find out, and what it is we're going to turn it into a rectangle. So what we're going to do, we're going to just cut off the triangle at the side here. So the purple line I'm drawing is parallel to the height, it's going directly upwards, and I'm going to cut off the triangle that I'm shading in. And then what we can do is we can take that triangle, we can move it to the other side of the shape, and we can slot it in. Don't even have to rotate it, just slot it in exactly as it is. And what I want you to do is just look at the triangle I've just filled in there, and look at the relative size of it and compare it to the triangle that we cut out. Now what you should see is the triangle that I cut off the right side and the triangle I've drawn on the left side are exactly the same size. So if you cut off the triangle on the right and you stick it in on the left, what happens is you form a rectangle. So I'm just going to rub out the triangle that I cut out, and you should start to be able to see that what I've got left over is actually a rectangle. We cut off triangle on the right hand side, slot it in to the left hand side, and now we have a rectangle. And because you can change a parallelogram into a rectangle, it has exactly the same formula. So a parallelogram, the area is the base multiplied by the height. A good way to think about it is that it's a tilted rectangle. It's tilted in a nice even way, so we haven't actually changed the area. So if we did 100 times 133, we would get 13,300. Then it's an area, so we need our units, centimetres, and we've multiplied two different centimetre measurements together, so it's centimetres squared. One final thing to note is that the parallelogram had 3 measurements: the 100 for the base, the 133 for the height, then had a diagonal measurement of 139. Now, notice that we haven't used that diagonal measurement, so I'm going to cross it out. And what happens is you'll often have extra measurements on diagrams like this that are meant to test that you understand how these diagrams work, because if you're only given the key information you need, then you could get the answer correct by a fluke by just multiplying everything together. That's just to stop you from multiplying all the different measurements together. You have to ignore that third measurement. So let's try that method again with question 2. So we're going to identify the base, which would be 79 centimetres. We're going to identify the height, which is at a right angle to the base, so that'll be 123 centimetres, and we're going to ignore the 125 centimetres. That's the diagonal edge. It's not at a right angle to anything else, so we're not going to use it. That means we're doing 79 multiplied by 123. I'm going to be using a calculator for these questions. If it was a non-calculated question, you'll typically get easier numbers that you could do with a simpler method. So 79 times 123 is 9,717, and looking at the units, it would be centimetres squared. Following the same method for question 2, find the base, which is 96 centimetres. Find the height, which will be at a right angle to the base, which is 152 centimetres. We're going to ignore the third measurement, the 154. It's not at a right angle to anything, we're not going to use it. And we're going to multiply our two numbers together. So 96 multiplied by 152 will give us 14,592. And again, it's going to be centimetres squared. Question 4, we have a base, which will be 119 centimetres. We have a height at a right angle to the base, which would be 162 centimetres. We have a third measurement we're going to ignore, which is the 165. That's not at a right angle to anything. And we're going to multiply those two numbers together. So 119 multiplied by 162 will give us 19,278 centimetres squared. Now moving on to question 5. So again, we've got the base, which would be 86 centimetres. We've got the height at a right angle to the base, which is 131 centimetres. We've got the third measurement we don't need, 134. And we're going to multiply our two numbers together. So 86 multiplied by 131, and that gives us 11,266 centimetres squared. Moving on to the medium questions, and we're now going to find the area of kites. So looking at question 1, we're going to look for angles that are at a right angle. Now on exam paper this should be labelled, and what you're going to find with a kite is that the two interior lines joining the top and bottom, the left and the right, those two lines join at a right angle. Now the angles on the right, for example the angle I'm just labelling here, that angle is not necessarily going to be a right angle. In fact, most of the time it's not going to be a right angle. So looking at our previous definitions, you might be thinking, well, to find the area, we do base times height. Looking at our numbers, got the 135, which I'm highlighting in green, and that goes all the way across. And we've got the 140, which again is going to go all the way across. Now, while it's not 100% clear if that green line is actually the base, it seems like the widest part of the shape, not kind of the top or bottom as you used to, the blue line definitely is going to be the height. But what I've been teaching you is that when we're saying base times height, it's not always clear, but what is always clear is that those two lines have to be at a right angle, and those two lines are indeed at a right angle. But as we see at the bottom with the little definitions, a rectangle is base times height. So if we did base times height, we're always going to get a rectangle. Now, in a parallelogram, it might be a tilted rectangle, but with these kites, these are clearly not rectangles. But we did do base times height, we would get a rectangle, and it would look like this. I'm just drawing the rectangle that we would get if we did base times height. So firstly, I'm drawing lines that are parallel to the height in blue. Now, let's neaten up that rectangle so we can see the next step of working out more clearly. And go over about the labels for the width and the height as well. So clearly, if we do base times height for a kite, we're getting a shape that is way too big. So what do we do? Well, it's all about the proportion of this rectangle the kite is taking up. So for example, I'm just going to colour in a triangle in green. Now, this triangle that I've coloured in green, it is exactly half of the outer triangle, which I'm colouring in a darker green. Two green triangles are the same size exactly. So the kite is taking up half of that kind of quadrant of the shape. I'm now going to colour in another triangle in blue. And again, the blue triangle is exactly the same size as the blue triangle I'm colouring in on the outside of the kite. So again, this triangle is taking up half of this quadrant of the kite as well. Then I'm going to colour in a quarter of the kite in purple, colouring in the triangle. And again, that triangle is exactly the same size as the triangle I'm colouring in on the outside. So again, in this quadrant of the kite, it's only taking up half of the rectangle. Finally, I'm going to colour in the last part of the kite in pink. And again, the triangle I've just coloured in pink is exactly half of the full rectangle. It is the same size as a triangle I'm colouring in the darker shade of pink. So what does this mean? Well, what it means is the kite is half the size of that rectangle. So how do we get the rectangle? We did base times height. And then how do we get the area of the kite? We have to divide that by 2, because it's only taking up half the size of the base times height. It's very similar to find the area of triangles, and you'll notice that the kite is made out of triangles. So it's kind of following a combination of the triangle formula, where it's base times height divided by 2, and the rectangle formula, where it's base times height. So for question 1, we would do the base, or we could say the width, 135, multiplied by the height, 140, and then we're going to divide by 2. You don't have to worry about getting an answer and then dividing by 2. You can write all of that into a calculator all at once. Because multiply and divide are opposites of each other, then they work on the same level as BIDMAS, so you're always going to get the same answer. So on a calculator, I'm going to write 135 times 140, then divide by 2, all on one line, and the answer I'm getting is 9,450, and looking at the units, it's centimetres squared. Even though we're divided by 2, we still multiply together 2 lots of centimetres, and that was the only bit that reference centimetres, so it's still going to be squared. So moving on to question 2, we'll practice this method. So we've got our height, which is 220. We've got the width, or the base, which is 199, and we can see that those two lengths are at right angles. And in a kite, these are always going to be on the inside, with inside lines drawn on the shape to show those. The 117, which is the length of one of the diagonal sides, is not going to be used. And the 186 is also not going to be used, because those are not going to be at right angles. Those are there just to test you and make sure you understand the kite, way to kind of test that you know what you're talking about. So those numbers are just there to confuse you. So we're going to do 199 multiplied by 220. We'll need to divide by 2 because it's the kite. Again, remember, with triangles, you divide by 2 and find the area, and kites are made out of triangles. So we're going to do 199 multiplied by 220. We're going to type in divide by 2, that's very important, and we should get in 21,890. And with our units, again, we are centimetres squared. Moving on to question 3. So we have our height, 140. We have the width, 129. It's at a right angle to the height. So we're going to multiply those two numbers together. We don't need 77, and we don't need the 117. Actually, I'm going to run out of space for working out, so I'll do the working out for this one above. So we have 129 multiplied by 140 divided by 2. Type that into a calculator, and the answer is 9,030. Again, centimetres squared, centimetres. Looking at question 4. So our two measurements at right angles are the 240 and the 234. The measurements we're not using are the 150 and the 187. So we're going to multiply together the numbers. 234 multiplied by 240, and given it's a kite, we need to divide by 2 as well. We're going to type that into a calculator to get our answer, and we should be getting 28,080, and that'll be centimetres squared. Moving on to question 5. So again, your first step is always going to be identifying what the base and height are, which two measurements are at right angles. So we've got the 200, we've got the 188, so that means we are not using the 115, and we're not using the 164. So let's multiply those together. 188 times 200. We need to divide by 2, and the answer should be 18,800. And again, that's going to be centimetres squared. Last thing I want to do, I'm just going to make sure it's very clear which bit of working out belongs with which question. So draw a little arrow from each question, each bit of working out. Now, on the higher paper, you'll be asked geometry questions where there's lots and lots of different calculations to do in multiple shapes. So always make it really, really clear which calculation belongs with which shape, either with labelling with arrows or maybe labelling with numbers to show what belongs with what. Moving on to the hard questions, and now we're going to find the area of trapeziums. Now, like all quadrilaterals, the base of the trapezium formula is base times height. So it works very similarly to the others, but there is a difference. So it's not exactly base times height. So we'll come back to this formula in a moment. Let's take a look at question 1. Now, let's say we said that the base was 82 and the height was 70. That would make a rectangle that was the width of the base. So just draw on an approximation of how big this rectangle would be. It would be coming out here. So we can see base times height with 82 and 70 is going to make a shape that is a little bit too big. It's kind of similar to the parallelograms with the two triangles on either side, but in this case we've got an extra triangle on either side. There's nothing to cut out and replace. So that's too big. Now, there is an alternative, and it's all about, what exactly is the width or the base. It's a bit ambiguous. We could say that 57 is the previous questions we have been taking labels on the top of the shape to be the base. And if you rotated that trapezium around, we could put 57 on the bottom, and the height is still 70. Now, if we did 57 times 70, that again is going to make a rectangle. And let's just draw on an approximation of how big the rectangle is going to be. Now we can see with this rectangle, it's going to be a little bit too small. So it can't be base times height with those measurements either. Now, the base at the bottom and the base at the top were both at right angles to the height, and the height didn't change either way. So I think multiplying by the height is going to work for us. But what about the bases? Well, the first base, which we call base number 1, that was too big. And the second base, which I'm going to call base number 2, that made a shape that was too small. So if one was too big and one was too small, what we can do is we can add together two bases, and what that does is it gives an average of the sizes of those two bases. So the average size is going to be in between the length of base 1 and base 2, and that's actually going to give you exactly the right width. The order we do that in as well is very important. So with the kites, we could divide by 2 whenever we wanted, because we're only doing multiplying and dividing, which are on the same level of big mass, it doesn't make a difference. But now we're adding last in big mass. So I've put brackets around the whole thing, just so we do things in the correct order. So you add together the two bases, you divide them by 2 to get an average size of the bases, and then we multiply by the height. So looking at question 1, we've got the two base 57 and the 82, and we've got the height 70. Now, I don't have a lot of working out space here, so I'm just going to do these on my calculator. So I'm going to do 57 plus 82, so it's going to be 139. I'm going to divide that result by 2, and that gives me an average base of 69.5. The height is 70, so we're going to multiply those together to get our final answer. So 69.5 multiplied by 70 is going to give us 4,865, and our units are in centimetres. One more thing to note, we didn't use the 71 centimetre measurement. So again, they're not at a right angle to anything else that are going to be there to confuse us. Moving on to question 2. The first job is to identify what we're using. So we've got the 172 and the 246, and they are at a right angle to 209. So we've got height and we've got two different bases. So we need to find the average of the two bases. Because we're doing base times height and we've got two bases, you need to find the average of them. Again, we'll do that on a calculator. So 172 plus 4246, get an answer, and then divide it by 2. That should give us 209. You'll see that 209 is roughly in the middle of the 172 and the 4246. Then we're going to multiply that by 209 because the height, coincidentally, is the same size as the average of the base and height of the two bases. So let's multiply those together, and that's going to give us an answer of 43,681, and that's in centimetres squared. Moving on to question 3. Now this is an example of kind of bases and heights and widths and lengths all being kind of ambiguous terms. We could say here that we've got two heights. We've got the 210 and we've got the 116. And because of the rotation, it's not really clear what a height is. And they're at a right angle to the 163 centimetres. So sometimes it might not be that you've got two bases you have to find the average of. It might be that you've got two heights you've got to find the average of. So we're going to find the average of the two heights, so 210 plus 116. And that will give us 326. Then we divide that answer by 2, and we get the average of our heights is 163. I'm just going to write that at the top because we're in out of working out space. And again, the width is also 163. So we're going to multiply those together, and that will give us our final answer, which is 26,569, and we're working in centimetres, centimetres squared. And again, it's worth pointing out we do have measurements like the 170 and the 212 in the previous question where we haven't actually used them in our calculations. They're just there to kind of trick us, to make us really think about which numbers we actually do need to use. Okay, now looking at question 4, again we need to identify what we've got. So we've got two heights, we've got one base. Again, it really doesn't matter which way around you get these. You get them the wrong way around, you get the same answer. If you call them length and width, again you get the same answer. They're ambiguous terms. What matters is these measurements are at right angles to each. So looking at the two heights, we've got 147, we've got the 105, we're going to add them together and divide by 2, and that's going to give us 126. So that's the average of the heights. We're going to multiply it by the width, which is also 126. Now you might have noticed I can get the same numbers for the average of the widths and the heights. Now that's just to a consequence of the way I've drawn these diagrams to get them to fit on the page, but you are going to get all kinds of numbers, and you'll see with question 1 they weren't the same, so don't always expect these to be the same number, they won't be. So we're going to multiply 126 by 126, and that gives us 15,876, and we're working in centimetres for all these questions. And again, with the measurement we didn't use the 127. Now moving on to question 5. So we've got two bases. We've got the height. So now on my calculator, I'm going to find the averages of the heights. So 26 plus 97 is 123. And divide that by 2, and we're going to get 61.5. We're going to multiply that by the height, which was 61. And that's going to give us our area. So our final answer is going to be 3,751.5 centimetres squared.